My name is Mark Pilger. I'm president and owner of SIP Corporation. And we're actually the oldest manufacturer of reel grinders in the United States, been doing it since 1902. Question for you. Is today's golf course technician's job more or less difficult than it was 25 years ago? Who thinks it's less difficult? Who thinks it's more difficult? My God, you're a smart group. It's more difficult because the equipment today is more complicated, right? But also, you're having to deal with things like lower height of cut and modern cutting units, which require much tighter tolerances. Competition courses, there's less rounds of golf being played, so you have to have a better quality course to attract as many golfers as you can and as many rounds of golf as you can. And today's budgets, when I first started in the business, the budgets were controlled by the superintendent. He was given a capital equipment budget, he was given a operating budget, and he could spend within that budget, he was fine. Today that doesn't happen anymore. You got all kinds of committees and oversight that doesn't allow you to spend it, and if there's any way they can cut that budget on you, they're going to. In addition to that, the golfers that play on your course have much higher expectations. They all want to be playing at Augusta, right? So that means that you have to get better conditions on your course. And that, again, we talked about it, lower height to cut. Okay, that means faster greens, and you're going to have more play, hopefully. You also end up with a superintendent wants to do more aeration, more top dressing, and more frequent mowing. That means that you have to do more with less. And so what we're here to do is talk about the grinding part of it and how we can get more for less with the grinding. And we have a concept we call total parallel grinding. And it's 5 things you want to do when you're grinding your reels. First and most obvious is, anybody? Sharpen. Okay. You want to be able to add relief if necessary. You want to grind the reel and the bed knife straight. You want to grind the reel in a cylindrical, get rid of the cone shape. And you want to grind the bottom of the reel parallel to the bottom of the rollers. Of those 5, 3 need to be done within a certain parameter. Okay? Straight, cylindrical, and parallel. Now, 25 years ago, you could grind a reel straight to 10 thousandths and you'd be fine because you're going to probably back lap it in, get everything running true on it, right? And you can get them cylindrical within a 32nd of an inch or 30 thousandths, and you were fine because you had all kinds of adjustments on the old cutting units. And parallel, that basically ties in with whatever your height to cut is. You're really trying to get your height to cut within 10% of being true. So if you're cutting at a quarter of an inch, 25 thousandths out of parallel, you're still fine. What do we have to do today? Well, today you're trying to eliminate backlapping in most cases, so you're trying to you got to get your reel and your bed knife true to within a thousandth of an inch. Because of the adjustments on today's cutting units, they require you to get the reel cylindrical within 7 to 10 thousandths of an inch. Toro, John Deere, they say 10. Jacobson says 7. And you want to get the bottom of the reel parallel to the bottom of the roller, again to within 10% of your height to cut. And I'm sure most of you are cutting at 1/8 of an inch or less, right? So that means that you have to have that bottom of that reel parallel to the bottom of that roller within 10 thousandths of an inch. So you can see the tolerances that we have today are significantly tighter than the tolerances you would have had 25 or 30 years ago. So again, what we do with our system, with the total parallel grinding, we again will grind straight to within a thousandth of an inch. Everybody should be able to do that. Again, that eliminates the need for backlapping. Anytime you have more than a 2 or 3 thousandths gap between the reel and the bed knife, what's it going to do? It's going to start tearing instead of cutting, right? So you need to make sure you have less than a 2 thousandths gap anywhere along the bed knife. And if you're running light contact, that means that if the reel is straight within a thousandths and your bed knife is straight within a thousandths, there's never going to be any place where the gap is going to be greater than 2 thousandths of an inch. Okay? We'll grind cylindrical within 2 thousandths of an inch. Again, the requirements are 7 to 10. We can do it within 2. And finally, grinding the bottom of the reel parallel to the bottom of the roller. Again, we're going to do that within 2 thousandths of an inch. Now, 2 issues with bed knife grinders. Mounting the bed knife without distorting it. Bed knives are very easily distorted. In fact, that's the way you adjust most bed knives today, is you distort it to try and get it to match up to the cone shape of the reel, right? And the second is being able to grind enough relief on the top face of the bed knife without some part of the bed knife shoe interfering with some part of the grinding head. Okay. So what I'm talking about there is you've got a grinding head here and you've got the angle set. You can see that through the magic of computer animation, it goes right through the motor. That doesn't happen in real life. You have to reset your angle. So what we do is we put the grinding motor underneath, because we know with absolute certainty there's never going to put anything underneath or in front of the bed knife. The problem with that is now how do we grind the front face? We'd have to take the stone off, flip it around, do all kinds of stuff like that. So what we decided to do instead was just go ahead and add a second grinding head. So now we can grind both the front face and the top face at the same time, and that cuts our grinding time in half. And as you can see, there's no problem with anything interfering with the bed knife because, again, the motor is down underneath. Now, the first benefit, obviously, is it's going to be faster because you're grinding both faces at the same time. But also, the second benefit is, and it's not so obvious, is that because you're grinding both faces at the same time, instead of, if you grind one face, what you're doing is you're grinding the top face down until it gets the edge on, then you rotate the bed knife and grind the front face to true it up, right? So now what we're doing instead is we're grinding both faces at the same time. They meet sooner, taking less metal off that top face, and typically we see that the bed knives will last about twice as long. The first problem I mentioned was the bottom support, or was the being able to mount the bed knife without distorting it. And so what we have is our bottom support pallet, and the way that works is you've got a shaft and a ball, and that is a line and a point, or the geometric definition of a single plane. When you set that bed knife on there, there's nothing for it to distort against, nothing for it to twist against. So when you clamp it down, it will stay in the same position it was when it was relaxed. And because of the fact that we've got the motor underneath the grinding stone, we don't have any problem with the grinding head interfering with any part of the clamping mechanism either. That's one of the main reasons why you see the end point clamps that they use, or the magnets, because if they put anything on top of the bed knife, it'll interfere with the grinding head. By putting the grinding motor underneath, that allows us to do a better clamping system by using the clamps on top of that. 5 minutes, I think we're just about done. To that, we've added a pin alignment system, and what that pin alignment system does, while going back to the bottom support, the plane that's defined by the shaft and the ball has been adjusted to be parallel with the grinding head travel. And so it's going to automatically grind the top face of the bed knife parallel to the bottom of the bed knife within 1 to 2/1000ths of an inch. By adding a pin alignment system, what happens here is you've got 2 precision pins that are located onto the pallet. You put your pivot bolts back in the bed knife, slide them back against those precision pins, and now the front face of your bed knife is going to be ground parallel to the pivot bolts. Okay? In addition to that, we have an optional pallet, which is our V-support pallet. That's the one that's mounted on this grinder now. And that V-support is like V-blocks that are mounted again on a precision surface. So when you mount the bed knife, you just set the pivot bolts down in that V, and it is automatically aligned again to be able to grind the top face of the bed knife and the front face of the bed knife parallel to the pivot bolt within 1 to 2/1000ths of an inch. The differences in the 3 pallets is on the bottom support pallet, it's very universal. It'll grind anything. Okay? It's touch alignment on the front. It's properly aligned to the bottom. It takes about 2 to 4 minutes to load a bed knife because you have to go through and do a touch on the front, get everything lined up properly. Now, if you add a pin alignment system to it, that will it's better. It works better with the pivot bolts, although it will still work without them. You just can't use the pin alignment system. It grinds both the top parallel to the bottom, and it grinds the front parallel to the pivot bolts. The big thing about it is it only takes about 30 seconds to load because you don't have to go through any of the alignment procedure. And finally, with the V-support pallet, it does require pivot bolts, okay? But it grinds both the top face and the front face parallel to the pivot bolts. And finally, it is ready to grind in 15 seconds. Okay, very good. Thank you very much. I appreciate your attention.